Good morning to everybody, ladies and gentlemen. This morning we start with the international session of this workshop. And in the first part of the morning, we have the session of networking. In this session that will be held in English is dedicated to the project that are in a relationship with Life Agrestic, and I thanks to all the specialists, all the responsible of this project that will participate this morning with in this session. And the project that will be presented in this session will be Great Life, is growing resilience agriculture, and it will be presented by Professor Giovanni Dinelli from the University of Bologna. The second project is Life Agriculture and Livestock Farming Against Climate Change in the Emilian Apenines, and it will be presented by Luca Filippi, Consorzio Di Bonifica dell'Emilia Centrale. The third one is Driver Farming, Crop Diversification and Low Input Farming across Europe, from practitioners' engagement and ecosystem services to increase the revenues and value chain organization, presented by a colleague from Spain, Raul Zornoza Belmonte from the University of Cartagena. The fourth project is Life ADA, Adaptation in Agriculture. It will be presented by Giulia Balugani, UnipolSai Assicurazioni SPA. And the last one is H2020 AGROMIX, AgriForestry and MIXed Farming Systems, presented by Alberto Mantino from the Sant'Anna, Scuola Superiore Sant'Anna di Pisa. Thanks to the speakers, and at the end of the presentation we pick up all the questions from the people that follow this networking session, and I leave the floor to Professor Giovanni Dinelli from the University of Bologna for Great Life.
Good morning. I try to open, thanks for the introduction. I try to open the file, just 1 second. Okay. I share the screen. Sorry. Where is the sharing? Here. Okay. Here. Okay, good morning to everybody. So my name is Giovanni Dinelli. I'm a full professor of agronomy at the Department of Agricultural Science of the University of Bologna. And I am also the coordinator of this life, entitled Resilient Agriculture for Climate Change Adaptation. Here you can see our menu briefly. Why Great Life? The Great Life approach. We will speak about also our triple approach as concern the agricultural sector, as concern the food, and also concern the consumers. So, but why Great Life? So the basic concept of our project can be summarized here in this slide. So we believe that in some way the consumer can have a quite strong impact on the climate change. And briefly, why? So the reason is that you can see, as you can see here, the agricultural sector produces more than 25% of the greenhouse gas emissions. That is a quite huge value. You consider that Greta Thunberg stresses us on the transport, on the effect of the transport, but you can see that the transport has a less impact as concern less than 40% with respect to the 25% of the gas emission of the agricultural sector. And you consider that it's clear that the industry produces more greenhouse gases, approximately 32%, but you must consider so that the domestic production of the agricultural sector is less than 10%, while the industry, in terms of money, produce more and more. So the gross domestic production is more or less around 40%. So if you consider the balance between the greenhouse gas emission and the value is quite a strong impact of the agricultural sector. And you must consider also that approximately the 80% of these 25% of gas emission are mainly due to the meat production. So the meat production has a quite strong impact on this. And as you can see, for example, here, the consumer, I'm not speaking about the fact that all the people must be vegetarian or vegan, but in any case, you can see the different impact of dishes based on vegetal plants such as legume, rice, carrots, and potatoes with respect, for example, dishes containing meat or dairy products and so on. So the impact is from 10 to 25 times less. And in addition, we know also that different type of agriculture can have also different impact in terms of impact on the environment. For example, you can see one of the several papers published in the last decade reporting, so the different impact, for example, of the agriculture, of some agricultural type of conventional agriculture with respect, for example, organic farming. And you can see also in terms of climate and in terms, not only in terms of ecosystem service, in terms of soil and so on, you can see that in general, organic farming is less impacting on the environment with respect to the conventional farming. Finally, so what is the conclusion? So that the consumer choice can have a strong impact on the mitigation, because it's clear the agri-food sector produces what the people want. So this is the basic idea of our project, how to act in this way. So our project starts from the school canteens. The aim is to engage the young people, the young kids, the young girls, because in this way, the education of the child means also to engage the family. And also engaging the family, this could be also a quite strong impact in terms of consumer choice. And finally, the consumer choice can have a quite strong impact in terms of adaptation and mitigation. So what are the messages? The message is less meat, eat less processed food, less food waste, more vegetable protein, more organic food, more diversity in the diet. That is another important aspect, because if the people eat each day the same type of dishes, it's clear that also the agri-food sector produce the monoculture, so that's the consequence. And more diversity on our dishes means also biodiversity in the field, more kilometers, zero kilometer, more awareness about the food sustainability in general. So, and this is our approach is mainly based in our project on this. And it's clear that from one side, we can say that agriculture is a victim of the climate change, is affected strongly also by the climate change, no? And our approach was mainly based on 3 levels. Here you can see the partner of the Great Life. Our project is a small project. You can see the University of Bologna. You can see Alcenero, which is a quite famous label of the organic products. The municipality of Cento, that is a small town in the province of Ferrara, and the Kilowatt, which is an agency for the communication, and LSCA from Turin, which are very skilled on the life cycle assessment. And the basic idea of the project is to produce an effect, to promote a change at 3 different levels. First of all, we are trying to convince the farmers to modify, to adopt sustainable agricultural protocols. From the other side, it's clear that we can say, we can speak with the farmers, but the farmer needs also an economic positive feature. So, and the only way is also to include at the social level is to stimulate the people to buy this product coming from a new type of agriculture, and from the other side also to convince the people that they have also to change something in what they buy each day for eating. And as concerned the agricultural sector, the core of the program of the project was to substitute the maize with millet and sorghum. Why? Because are crops that are resilient, and we know that, for example, in the last decades we lost more or less the 50% of the surface cropped area devoted to maize due to the climate change, mainly because we have less and less water during the summertime, and this causes a big problem in cropping maize. So the idea is to substitute maize with millet and sorghum. Millet as concerned the food application, sorghum for the animal feeding, and because they are good competitor with wheat, they are less susceptible to a lot of fungal diseases, and so there are no risk of mycotoxin like for maize. They are less susceptible to insect attacks. They in general, they have a reduced agronomic needs in general. We try to promote this also with other agrotechniques. So first of all, to the minimum tillage, to reduce the tilling of the soil, to maintain the soil covered for the great part of the year. So it means non-naked soil. And finally, the crop rotation that is really, really important also for this. So we have tried to promote this, and at the same time, we have developed a web tool for the assessment of the environmental and economic impact. So now the tools is available, and this is based on life cycle assessment. And here you can see some result of our project. Here you can see, for example, the impact in terms of kilogram of carbon dioxide equivalent per hectare with the maize produced according to our scheme, because in any case, we try also to involve, to maintain also the maize. That you can see, for example, of using the grid life approach. You can see here 3 farms, the comparison with respect, for example, an organic maize produced in Switzerland, or also considering the conventional Italian production of maize. You can see the very low impact of this protocol of production. At the same time, you can see the same for the sorghum, and also in this case, you can see our protocol of production has a quite strong reduced impact in terms also in this case of carbon dioxide kilogram equivalent per hectare. And finally, the grid food. So the idea was to try to develop also a sort of chain, a supply chain. The farmer produces resilient primary products. At the same time, there is a transformer that transforms this product in product for the market. And here you can see some of this product. For example, here you can see some biscuit, and this biscuit, as you can see, are now sold with the label of the Life. You can see here the Life logo, reporting also the information that this is not only an organic product, but is also an organic resilient product. And this is the best way also to promote the great life agricultural practices to the farmers, because the farmers know that they can produce millet and sorghum, and they know that there are someone that is welcome to buy this product for producing a biscuit like this. But you can see also other products that were developed during the 3 years of this project that will finish the March of the next year, 2022. And finally, also the involvement of the school, according to, for example, you can see here some of the new dishes that we developed with the sorghum and millet. And for example, here you can see also the appreciation of the young people of this biscuit produced by Alcenero. You can see that in general was really appreciated by the young student, and also here you can see the 100% hit all the products. So, and because we prepared also this booklet reporting how to cook millet, how to cook sorghum, and how to prepare some delicious dishes like here. And here you can see one of our chefs involved. This is Pina Siotto, which is she's a chef, a vegan chef, and you can see also here in this picture. But in addition, we try to develop with the municipality of Cento, so that to promote the resilient product, also involving the so-called green public procurement, because we have tried to draft a first resilient food public purchasing scheme in order to integrate the sustainability in the public procurement. That is another quite relevant aspect. And finally, our community, because it's clear we involve at three levels, the society, the farmers, the producer, but also the consumer in general, not only working at the canteen level, so in the school, but also in general to promote a community of people. And here you can see some of our events that were organized here in Bologna. We organized several events, also with some leaflet. So the main idea is to involve as much as possible the people communicating what is the message of an organic and resilient product with respect and also the positive impact for the environment and for the fight against the climate change. And thanks for your attention.
Thank you very much, Giovanni. It's real clear. You stay also in perfect time in your speech, and I think that it was really there is a good connection with Agrestic, our project, because we are very focused on the cropping system, as you did in your project. And it is clear that we take in account in both the project this aspect to insert new crops in a cropping system, existing cropping system, in the best way to maximize the benefits and the resilience. And also another point of networking is to brand the production, to achieve a brand recognized and in which the consumer can find the value of the production. Thank you very much. We wait for the question at the end of the session. So the next speaker is Luca Filippi from Consorzio Di Bonifica dell'Emilia Centrale, and he will talk about life agriculture. Thank you.
In a second, I'm trying to share my screen. I did it before, and now okay, so hello to everybody. First of all, I would like to thank Life Agrestic staff for inviting us. I'm sorry I cannot be there. Maybe I hope there will be another opportunity also to have you in our events that we'll plan in the next years. So I'm an architect, landscape architect. I'm project manager of Life Agriculture. I work for Watershed Management Authority, specifically to the environment, agriculture, and forestry sector of this authority. It's a sector that already developed 3 life projects. So I mean, we are we have quite strong experience in this kind of projects. So this is the summary of my presentation. I will briefly introduce life agriculture. We'll take a look to the territorial context that is quite key also for understanding the aims and what we're doing. We'll take a look on the, let's say, reading tools that we are developing for understanding this context. And then we'll eventually we'll also take a brief overview on our first year of demonstration activity. The project started in September 2019, so we just, it will last for 4 years till August 23. We just delivered our midterm report. Still today, I mean, I will show you some results, some let's say, documentation about our demonstration activity, but it's still, we are still at the beginning also of the monitoring activity, so we cannot really talk about results. So the partnership, beside, I mean, our watershed management authority, that is the coordinator, we share the project with another watershed management authority that is called Burana, that covers the territory of the Modena province, with a research center on livestock production, CRPA, and a national park authority, Parco Nazionale Appennino Tosco-Emiliano. So the aims of the project are the following. Life agriculture investigates the contribution that livestock farming can play in mountain areas for soil protection and climate change mitigation. We do this by carrying on demonstration monitoring activities. The demonstration regards best practices related to breeding, effective for the protection of soil organic carbon and the reduction of greenhouse gases emissions. And then we also test and evaluate a contract solution for the production of agro-environmental climatic goods. So this is a key output of our project. I won't talk too much about it. I will focus more on best practices. Still, I would like to stress at the beginning the fact that I mean, there's a strong, let's say, territorial approach in our project. It's really key for us, the upscaling of the best practices that we are testing and evaluating. And we're doing this through this contract solution that we are constructing on the, let's say, on the territorial area on which our activity, is focused. So the expected results are the following. So we work on soil organic carbon on the 15 demo plots that we are working on. These are the kind of land use that we are working on. These are the baseline. We think we can at least maintain this baseline. We think there's also a margin for improving, but I mean, we think the real improvement will regard marginal fields. Now we'll see that later on. Then we are working on the total stock soil organic carbon at the level of the project territory, and eventually we work on the global warming potential of the 15 demo farms involved in the project, and we think we can achieve a 5% decreasing at the end of the project, period. So let's start with the context. So we think the context where we are working, the Emilian Apenines, is quite key, for treating the issue of soil threats in the mountain territory of Southern Europe due to unsuitable agricultural practices. We think it's also a paradigmatic context for testing a territorial transition towards sustainable use of agricultural soil, mainly due to the high level of productive and social organization expressed here by the Parmigiano-Reggiano supply chain. So let's take a quick, let's say, visual let's say, overview on this context. For those of you that doesn't know this this territory, I have to underline the fact that is a structure on this quite diffused network of cooperative dairies and livestock farms, linked with mainly linked with the Parmigiano-Reggiano supply chain. A really strong supply chain that allows also the territorial reproduction of this context. It is quite marginal, in terms of socio-economical activities. Beside that, so agricultural practices, soil management. I cannot stop on each one of these slides, but I mean I hope they are quite clear. Erosion, landslides due to agricultural activities, limitation to land use, due, for example, to the relevant presence of stony skeleton in the soil. So yes, this the soil threats as a long-term, let's say, origin. It can be read through the landscape transformation, from let's say agroforestry system, or let's say intercropping systems, to let's say more specialized forage systems realized starting from the 60s and 70s of the last century, that produced simplification of the landscape structure, issue in terms of hydrogeologic risks because of the simplification also of the water management, and therefore now it's time to maybe to think again a new way of managing this landscape by introducing best practices that I mean we know from scientific research that are quite effective, but I mean it's necessary to test them and to evaluate in this specific context. So first of all, we had to read again this territory, producing a territorial reading of a mountain livestock and forage system. We used 3 reading strategies. An atlas, a cartographic atlas that specialized now the reading of this context. We are interested in producing also a geographic reading of this context, also because of let's say the territorial outputs that we need to produce. So a reading of the special complexity of a livestock farm today. Maybe later on we see some samples of this atlas, and it was also interesting to read the role of livestock farms in the production of agro-environmental climatic public goods from this spatial and geographic perspective. These are our 15 demo farms. We'll go through them later on. Second reading tools was the life cycle assessment. We use life cycle assessment not only for producing quantitative results, but also as a point of entry for describing farming styles, let's say managerial approaches, and also highlight weaknesses in our demonstration farms. I cannot enter into the results of the life cycle assessment, but I mean, for those that are interested, we'll leave all the slides. Then we did a deep reading also of soil management, of soils. We did deep soil characterization, and also we linked the soil characterization with soil management practices. We produce through this activity also a baseline value of the territorial carbon stock of our, let's say, project territory. Okay, now I will go through the demonstration activity. The demonstration activity was based, first of all, on the construction of work protocols that regards the entire productive cycle of dairy farms. So from let's say the livestock, let's say from the forage and crop system to the manure management, herd feeding, and also land improvement. Now, in this territory, land improvement really means also protecting the soil, and also allowing the continuity of agricultural activity. So we put a lot of stress on land improvement best practices, also due to the core of let's say the activity of watershed management authorities in the mountain territories. Okay, we see a sample of the toolbox that we realized, the toolbox that is based on 18 mitigation strategies. For each mitigation strategy correspond to several best practices. There are 18 mitigation strategies and 63 best practices in our toolbox. And the toolbox was eventually used for producing the work protocols that we see right now. Okay, this is a slide specifically focused on the land improvement best practices. We see them later. Okay, we can schematize the let's say the action at least on the demo plots through these 6 design themes. The introduction of herbages in the forage system of the Emilian Apenines, pastures improvement, grassland improvement, from crops to permanent grasslands, exhausted alfalfa meadow improvement, the use of intercropping for sustainable intensification of cereal farming. I cannot stop on each one of them. I will use 3 case studies to show you concretely what we are doing. So first theme, the introduction of herbages in the forage system of the Emilian Apenines. Herbages are not so used. The traditional rotation is based on actually should be based on 3-4 years of alfalfa meadows, followed by 2 years of cereal. Actually, what happens is that alfalfa meadows are not renewed so oftenly, so they can maintain for more than 6-7 years. They become almost grassland, low productive grassland. So we are also working, as we are doing, on this concept of efficient cropping system, introducing the idea of new rotation, although it's quite simplified compared to, let's say, what happens in the poplane, for example. So the idea of introducing at least 2 years of forage herbages after after, let's say, the years of alfalfa, herbages that can be introduced by no-till sowing. So it's also in the perspective of introducing conservation agriculture practices now. So let's take a view to this case study, Azienda Agricola Castellari, in the, let's say, middle part of the mountain district. These are the mitigation strategies that we identified to foster farms' environmental and productive efficiency. And these are an example of work protocols. So this is at least what we realized so far in these work protocols. So we haven't started so far the activities concerning, say, herd management. So I will talk only about what we did on the forage system. So in autumn 2020, we started by sowing forage winter wet on a traditionally prepared field. We came from an exhausted meadow that needed to be plowed. Actually, this is necessary now for entering into a no-till regime management. But at the beginning, when we confront ourselves with the exhaustive meadow, plowing is necessary. So then we did a work on forage species, varieties. We worked on drainage of surface water. We worked on slurry, high making, and then in summer 2021 we introduced our first intervention with sod seeding. We introduced a second year of herbage with the ryegrass, sowed at the end of summer season, so we on warm soil. This is another concept that we are trying to introduce, and these are land improvement best practices that we also introduced and realized. So this is a sample of the cartographic atlas. So this is the demo plot, 2.5 hectares, linked with the let's say a secondary say centrality of the farm. So this is the forage wet in March 2021. This is the making of the forage winter wet, quite high production. The farm was really satisfied by the production. That was also realized in the perfect time for having a very good product, also for feeding. This is a sample of the land improvement. There was the access to the field was problematic. It was due to infiltrated water. It was lighted down, so we realized the drainage, earth moving for let's say gaining again the right level of the road, and selective cuts. A second case study. In this case, we are working on let's say pasture improvements. It's a farm specialized with sheep. In this case, we started, we used the strategic use of grazing aimed at preventing maturation spreading of spring wheat species in spring. This was quite key. We see the pictures later on in order to introduce also new species, forage species by minimum by sod seeding in summer time. And also we realized relevant land improvement best practices to support pastures activities. We'll see them later. This is the demo plot. We see here.
Sorry, Luca. Sorry.
Yes, I'll go faster. Yes.
Okay, thank you.
So we see the spring wheat species that we try to contain through a strategic grazing activity. This is the drinking throat for grazing that we realized at the entrance of the field. This is an anti-wolf forest fence designed to refresh the pastures during summer heat. And this is the activities of overseeding realized with manual broadcasting. This is the grass seed mixer that we realized for the project. Okay, last case study, I will go really quick through it. Grassland improvements. The theme is that. Here we started by realizing overseeding operations since the first year, so since autumn 2020, and in summer 2021 we realized the second year of overseeding. This is the demo plot before intervention. These are some demo plot after rationalization works, selective cuts, mainly selective cuts, removal of large-sized stones. And these are the operation of overseeding that produced interesting results, productive results. We'll go. These are the other theme. I don't have time to go through. Exhausted alfalfa method of improvement, the use of intercropping. We also experimented bullatura, as I know you did. Okay, I don't have conclusions, but just end my presentation by focusing on the next activities that we'll implement in the next 3 years. We have 1 more year of demonstration activity with a key also monitoring of the results, environmental and productive results. We have to implement the Pact for Soil. We are working a lot on it, and eventually we have to produce a cost-benefit analysis that will, let's say, put together environmental and productive results, as I know from yesterday's presentation that you are also doing. So thank you a lot. These are our contacts, and I hope to be able to answer to your questions. Thank you a lot.
Thank you very much, Luca. We have very appreciated your project because I think that it is a project in a very sensitive area, as Apenines are, and not also for Emilia-Romagna, but for Italy. And we appreciate it too that you study agronomic actions, but also structural actions. Particularly, I appreciated a lot the activity you did on drainage, for example, and it is very important to save soil, to save erosion, and damage on the community. So, very interesting project. Thank you very much. So we go fast to the next speaker, Professor Raul Zornoza Belmonte, for DIVERFARMING, crop diversification and low input farming across Europe. Thank you very much, Raul.
Thank you for the invitation. I'm gonna start sharing. I guess you you see the presentation. Can you see?
Not.
Hmm?
Okay.
No, you see?
Yes. Yes.
No.
Thank you.
Okay. Perfect. I hope you, well, please let me know if there is a problem because you know that I don't have feedback when we share the screen. Well, as I said, it is a pleasure to share this event with you and showing some results about the Horizon 2020 Diverse Farming project that is related to crop diversification and low input farming across Europe. I am the project coordinator, but I am representing the entire consortium. So what is the general scope of our project? As it is included here is to increase the long-term resilience, sustainability, and economic revenues of agriculture across the European Union by assessing benefits and minimizing the limitations, barriers, drawbacks of diversified cropping systems. And we include within diversification, rotations, multiple cropping, that is the rotations within the same year, with winter and summer crops, and intercropping, both in perennial or woody crops and annual crops. Accompanied by low input practices, tailor-made to fit the specific characteristics of different pedoclimatic regions of Europe because we have differences in soils, climate, cultural practices, socioeconomic context, etc. So the different strategies have the same objective, but tailored to the specific conditions of each area so that we succeed. And also we are working through the entire value chains with the optimization, adaptation of the value chains to adopt to these new agronomic models. We are working with different case studies in the field. We have 25 case studies, as you can see here in the map. In the blue color, with this, as I show here, we have short-term case studies that started with the project. The project started in 2017. This is the fourth year of the project. So we started some case studies after a decision-making approach with stakeholders and end users to test new practices, new diversification systems that would be worth for the different locations, but also we included in orange color long-term experiments for more than 7-8 years, so that we had also more robust data to fit the project and mostly the models that we are developing. In addition, to increase the impact and outreach of the project, we have launched the Via Diverse Farming strategy that it is linked to our website, that we are engaging by volunteer farmers and agribusinesses, but most of our stakeholders that have been engaged are farmers to develop diversified cropping system in their farming, in the farms, as real scenarios, so that we ensure longevity beyond the project. And we are having different seminars and co-learning process in real scenarios, besides the 25 case study that we have in the project. We are 25 partners from 8 countries, as you can see in the map, but we want to increase the outreach of the project, engaging more and more farmers. And so we are working in the field, gathering different agronomic, environmental, and socioeconomic indicators, also making the analysis of the value chain. But since we have a lot of case studies and a lot of property measures, with this 5-year project and the budget is 10 million, it's impossible to speak about everything here. So I will focus on the effect of the crop diversification and low input management on soil carbon sequestration and storage and greenhouse gas emissions. This is the main topic of the events related to the live that is hosting the event. And also I will show only, because of time, 3 case studies that I included here in the red circle in Southeast Spain, where I am located, so I'm more familiar with this, with 3 different case studies I will show. So what we have done and the main result. In the end, I will show some conclusions about all case studies. So we'll start with vegetable intercropping in Southeast Spain, as you can see here in the image. And it is more common to have rotations or multiple cropping in vegetable production, but it is very difficult to find intercropping. So we wanted to check the benefits and also related to carbon change mitigation and adaptation. So we compare different crops. In this case, I will show the melon, typical in the region. I have here, and I show with this graph, a melon monoculture here with the different dots, green dots, the plants of the melon as a scheme here in a plot of 200 square meters. And we checked how intercropping with cowpea, with Viña unguiculata, it's a typical bean of Africa, but also in the southern Europe, it's very common. And we wanted to assess how it helps in improving ecosystem services delivery, including production. So we checked raw intercropping, in which we included 1 row of cowpea, as you can see here, between 2 rows of melon. We also included raw intercropping 2-1. So we have 2 rows of melon, and we included 1 row of cowpea to see if there is some competence between the 2 species. And also what we call mixed intercropping, that we have 1 cowpea plant between 2 melon plants in each row. So the density of the melon is the same, as you can see, we have the same density, but the density of the cowpea is changing in the different systems. And we also had a monocrop of cowpea, of course. To work with the results or the impact or challenges of the Green Deal and Farm to Fork strategy, and although we started before, we wanted to reduce the use of fertilizers, and including the legume, we wanted to mobilize nutrients in the soil by nitrogen fixation, but also activation of microbial communities. So reduce fertigation because the system is fertigated. So we irrigated, but also include the fertilizer by irrigation, but we reduce fertilization by 30% in the intercropping systems to check if nutrients are more available with the inclusion of the legumes. So I'll show here some pictures with the melon monoculture here, and an example of raw intercropping. You can see here the melon plant, and there are 2 rows and a row of the cowpea, or the mix in which it is totally mixed. In each row we have cowpea and melon. So what we observed related to soil carbon and nitrogen contents, we also, I don't show the graph, but we observed increases in production of melon because we need pollinators, and with the cowpea we had more flowers, and we attracted more pollinators, and we found more number of melons per hectare, so increased production. So it was highly positive. But also with soil organic carbon, as you can see here in this graph, we have first the melon monocrop with the lowest quantity, very low organic carbon content in this area. We are under semi-arid conditions, not only Mediterranean climate, but also Mediterranean, typical of Southeast Spain. But we increased after 3 years the carbon content in the soil with the introduction of the legume, as you can see here, but not only with the cowpea monocrop, but also with the intercropping system. And also the same with the nitrogen where we introduced the cowpea. So we reduced fertilization, external inputs, but we increased bioavailable nutrients in the soil by introduction of the cowpea, and also increasing the production because of the flowers. What about greenhouse gas emission? This is a cumulative values of 2 crop cycles, and with the different treatment, the melon monocrop, the cowpea monocrop, and the different intercropping system. This is CO2. We observe lowest CO2 emission from the soil. This is from the soil. Lowest with the legume, with the cowpea, compared to the melon monocrop and other systems, but increased with the intercropping in row. And we didn't observe this increase with the mixed intercropping, still figuring out how, why. are related to nitrous oxide emissions. I show here the lowest, again, emissions with the monoculture of cowpea, the legumes, lower emission, CO2 and nitrous oxide compared to the melon. But we also decrease this emission in nitrous oxide emission with a mixed intercropping, in which we have one plant of cowpea in the middle of two of melon in the same row. I want to show another cropping system, totally different, now with woody crops in almond orchards, also in southern Spain, in which we applied alley cropping, some perennial cropping. What we did is to compare the almond monocrop typical of the area with bare soil, highly intensive tillage, and we introduced the thyme. Thymus gemmalis is a thyme species typical of the area, and also caper in the alleys to check how it worked. And also we wanted to attract pollinator with this species, mostly with thyme, because it is essential to increase crop production, almond production. So with the thyme, we wanted to also attract pollinator when there is the blossom, the flowering of the almond in January. And related to carbon in the soil, I show here the soil carbon balance on the left. We see that there is a system that we are losing carbon. Owing to our climate, we are losing carbon, and also the management that has been traditional in the area, we are losing carbon. But with the monocrop, we have the highest loss. And you can see that with diversification, Caparis spinosa and Thymus, with time, we have decreased the loss. So with crop diversification, we are decreasing loss. And I show on the right how it has been decreased, because we increased with crop diversification inputs by biomass with new crops in the alleys, with new biomass in the alleys. We increased 55% of biomass inputs. We decreased CO2 emission with crop diversification by 20% compared to monocrop. And also we decreased erosion, so loss of carbon by erosion between 30 and 60%. Because in the monocrop, the soil is bare and erosion rates are high. So we have a vegetation cover as a cover crop that reduces loss of soil and also increases the carbon. I show here greenhouse gas emissions in the different rates in 2 years measurements from the soil. At the top, CO2, at the bottom, N2O. And in the different lines, in the different graph, I show the monocrop, almond monocrop in black, the caper in blue, and the thyme in red. And as you can see, no differences between the two species that have been introduced as monocrop. We reduced emissions of CO2 with some peaks in the monoculture, mostly related to most tillage events, because with the caper and thyme, we have reduced tillage because it's impossible, because they are perennial crops. So the tillage is related to just the near place to the tree. So we have decreased these emissions of CO2 and no effect of N2O emission. Last example, annual alley cropping instead of perennial. This is annual in irrigated citrus. You can see here the oranges in southeast Spain as well. We compared a monoculture with the alleys that are remain bare, typical in the area. In fact, here, since precipitation is so low, cover crops are not normal because there is a belief that they are going to compete with water and nutrients with the cash crop, and farmers don't want to use them. So we included diversification with fava bean and barley beds in rotations. You can see here the image of the monoculture, the photo, the aerial photo, and with the fava bean, increasing the cover crop in the alleys. Related to soil carbon content and also nitrogen, I show here in green in the beginning of the project in 2018, and after 3 years, we haven't seen any difference in carbon content. We observed that in the rain-fed almond, we increased the carbon, but here we haven't seen any difference. And we think this is because we are tilling a lot, because with annual crops, to prepare the soil for the different annual crop, we have to till. So we need more time to see the effect of crop diversification and the inputs of the crop residues. related to CO2 and N2O emissions from the soil. I show here some difference in CO2 emissions at the top, not below in the N2O. In black, it is the control, the monocrop, and then in blue, the diversified system. You can see here that in some periods, the CO2 emissions are higher when the soil is covered with algae crops, because there are more microbial activity, root activity, so are increasing the emissions, but not supported, but increases in soil organic carbon. We need longer periods here. So to finish, highlights with not only this case study, but results from most of them. The results are quite diverse, highlighting how the inherent characteristics of soil, crops, climate, and management can control these variables related to carbon sequestration and greenhouse emission. As a general pattern, there is a trend to increase organic carbon in soil with crop diversification and low input management practices. Related to soil greenhouse gas emission, they are highly variable, with some increases in some case studies in CO2 and even in N2O emission when adopting crop diversification, mostly due to higher activity in the rhizosphere. We are also measuring life cycle, making life cycle assessment to have all the system monitored related to CO2 emissions, not only those coming from the soil, to have an overall overview. Now working on, we don't have data yet. So I invite you to follow us in our websites and social media. Besides DIVERFARMING, we are part of the crop diversification cluster that has been created by different projects in Europe. And also we invite other projects related to this to join us and to increase the output of crop diversification or the outreach of crop diversification in Europe. And also follow us here, because we are about to launch an app. It is just Diver app, so that end users can check how crop diversification can affect some agronomic, economic, and environmental indicators with different climate change scenarios. So thank you very much.
Thank you very much, Raul. Very interesting presentation, focused on different cropping system than we faced in the previous live project and in Agrestic. Yes, very, very interesting. And we now give the speaker to Giulia Balugani for Life ADA, and thank you to Giulia.
Good morning, everyone. Thank you all for the opportunity of being here to present our Life ADA project. I'm Giulia Balugani, the Sustainability Manager of UnipolSai Assicurazioni, that is the leading partner of the project, and I'm the project supervisor. So I'll show you some slide. Can you see the slide? Hope you can see the slide. So about Life ADA, we decided to cover a challenge that is about climate change and its impacts on agriculture. Of course,
sorry, Giulia, sorry.
Yes.
Okay, now we watch your presentation. Sorry. Okay, it's okay now. It's okay now. Okay.
I'm sorry. as I was saying, the challenge that we decide to take over is about climate change and agriculture. And of course, our Life Ada project is quite at an early stage. So we can share today our goals and the way we are and we start to work to match our goals. So as you know, Italy is in Europe one of the most vulnerable areas to climate change. And we are facing, as an insurance company, we know it very well. We are facing increasing loss due to extreme weather condition year by year, and we can see it very well, for example, in our insurance data. So, of course, climate change has a huge impact on agriculture. And even if, of course, agricultural practices have always adapted to the weather conditions variations, now the frequency and the severity of extreme weather events is increasing so much. And it's difficult for farmers to become able to adapt in a quick way. So this climate change is severely impacting the productivity and the quality, even the capacity to survive of farmers, because it's impacting their the productivity, the quality of their crops. So it's a big problem for their profitability. And this is especially true for small and medium-sized farmers. So, and of course, I don't have to say how much the agricultural sector is important for our life and from a social perspective, and even from an economic perspective in Italy. So we, with our partnership, we decided to define a project that aims at increasing the producer organization farmers' capacity to adapt to climate change. So our targets are the producer organization and the farmers themselves. And the aim is to help them to become more skilled and to have more information and more opportunities to define measures and adapt to climate change. And what they need is, first of all, the knowledge of their risks and knowledge of their opportunities to protect from these risks. And the project is doing it by building tools that can help farmers to define their adaptation plans. They're very customized adaptation plans, so that can maintain their productivity and the revenues along the whole value chains. We were very aware that a project like this can be implemented only with a strong public-private partnership, because the challenges and the means that we can put in place needs a strong cooperation between the private sector and all different actors in the private sector and the public and public administration. So I think this is an important characteristic of the model we are trying to put in place, and we in our partnership, as we are going to see in a while, there are public administration, there are scientific institutes, there are producer organizations, and there is an insurance company. And I will go a bit deeper on our role in a while. So we decide to involve 3 supply chains, and there are very important supply chains because they are sectors and supply chains that can bring an important value added to our economy. It's a dairy supply chain, and specifically the one involved in Parmigiano Reggiano production. There is the wine production and fruit and vegetable supply chain. So here we can find production that are very important for our economy and our culture too, I can say. We defined a pilot region, that is the Emilia-Romagna region, where we have an important headquarter, and when we could find this very strong partnership and a very involved role of the public administration, and defined 3 more regions for the extension of the project during the project duration, that are Veneto, Tuscany, and Lazio. The farmers that will be directly involved during the project in the 4 selected region will be 6,000. And we are expecting to extend during the project our tools and our means to 15,000 of farmers at a national level. But the potential is much bigger, because in these 3 supply chains involved, there are 242,000 potential farmers. So this is our real target. And these farmer organizations involve 1.2 million of workers. So there is place for a huge impact on society and on people. Something more about our partnership, as I said. Of course, our project is co-funded by the EU Life program, and the project coordinator is, as I said, UnipolSai Assicurazioni. The scientific institutes involved are PAE Emilia Romagna, which is, of course, involved in defining climate scenarios, and the CREA Politica and Bioeconomy, politics and bioeconomy, that can provide us very strong knowledge on how the agricultural sector works, even in economic terms. We have the organizations of production of our farmers, and that are CIA and Legacoop Agroalimentare Nord Italia, and of course they bring to the project the knowledge of the sector and the relationship with our final target, that are our farmers. As I said, the Emilia-Romagna region is the public administration strongly involved, with the aim to find new ways to imagine the role of a public administration in supporting the increase of resilience of the farmers. And there is an NGOs like Festambiente with a strong environmental knowledge, and we involved Leita, that is a company between the Unipol group, and this is a innovation and big data analysis company, because we have the aim to go to involve our farmers in a very technological, innovative way. So what are the specific objectives of Life Adapt projects? As I said, we aim to support the producer organizations and directly farmers in identifying and planning actions that can prevent and manage climate-related risks. First of all, as I said, we need to transfer them more knowledge about what they are expecting to about climate change. So it's very important to define climate scenarios to understand what is coming in a very detailed way. So to define very effective adaptation plans is not sufficient having climate scenarios of Italy or even for a region, but you have to know what is or what will going on in your where you are in your territory. So we have to transfer them knowledge on climate scenarios, and we have to make them understand what are the risks they are facing and what measures they can they can put in place to adapt to these risks. And we plan to do it building some tools that can support the decision-making process, and tools that can be friendly, easy, but very rich and detailed. So it will be a challenge to define the perfect tool for this goal. And of course, there is like a strategy level, because this partnership will allow us to understand how at a regional level can be defined new policies to support the farmers' adaptive planning. This means how to invest in new resources, and maybe even how to use resources in prevention, to not use later resources in restoration, for example. This is the view. And of course, that there is a role for the insurance company, because for us as an insurance company, climate change impacts of climate change in agriculture is a big challenge. We want to have a social role, and we want to stay beside these important productive activities, but we have to make it sustainable in a 360 degrees way. So we need to understand how better identify risk, better prevent risk, how to help farmers to reduce risks in order to remain, in order to let this risk be insurable. So less risk to continue to insure them in the long term, despite the fact that we know that catastrophic systemic risk will increase. We, of course, estimates important impact for the project that are impact even on the environmental side, because this is an estimation made on 15,000 of farmers, and we expect lower emissions, less consumption of natural resources, and an improved resilience. So we will impact on different aspects. And an important part of the project is to punctually define, calculate how will be even the economic and social impact of the project, because of course we aim to define a model that will be replicable. So it's very important to be very clear on what this model can bring at an economic and social level. So just yeah.
Sorry, Giulia, a few minutes, please.
Yeah, 2 minutes on where we are now. Today we are at a very good point in the elaboration of climate scenarios that are going to improve risk maps, the forecasting models, and the future climate scenarios at this detailed level, as I told you. We defined a wide library of adaptive interventions that are both at the farm and at a broader supply chain level. And here in the library, there are skills on climate scenarios, skills of agrometeorologists, agronomists, and even the contribution from the risk management skills of insurance. And these will be included in the tool that we aim to give to the farmers, that will be used to the farmers to define their adaptation plan. And this is the last one. We are building the other tool. As I told you, it's a very critical point because it will have to be friendly and well structured. So we involved very different experts and external skills, even doing an hackathon, but even involving the agricultural sector, of course, in first. And we are building our learning community with an open course open to farmers and agronomists that is including a technical webinar, workshop, peer-to-peer meetings.
Okay. Thank you, Giulia. Thank you very much for your presentation. I think that is a very interesting project focused on the organization of supply chain. Very, very important is the point of contact with Life Agrestic concerning the decision support system, for example, to address the producer to the best practices to reduce pollution and to save resources, and it is a very important contact point with Agrestic, but also it's very important also to the theme of insurance for the farmer, but it is real actual in this moment for Italian agriculture sector, and it is also addressed to the non-parametric solutions, for example, and we watch to your project in a very interesting way. Thank you very much. So we have the last presentation. At the end of the presentation of Alberto Mantino, we also answer to the question we had in the previous project. So the floor to Alberto for AGROMIX. Thank you, Alberto.
Thank you, Gigi. I'll try to go quickly to leave some minutes for the question at the end of the session. So, good morning. My name is Alberto Mantino. I'm a researcher here at Scuola Superiore Sant'Anna. I'm an agronomist. I'm a member of the AGROMIX project, that is a H2020 project focused on the agroforestry and mixed farming system. And according to the vision of the Life Agrestit, we studied and implement the diversification of cropping system in order to create a more sustainable agriculture towards a more efficiently land use. This is the index of my presentation. I want to present you why and who and how we want to implement this project, and then I present you an example of our pilot project in AGROMIX. Why we think that mixed farming and agroforestry could be a solution for more sustainable agriculture. Mixed farming and agroforestry are based on the core of this diversification and increase the efficiency of the use of the inputs. In particular, we think that nitrogen cycle, carbon stocking, and soil fertility are very crucial and for more sustainable agriculture. And the idea is to mix, is to combine several aspects and several characteristics of cropping system. And the idea is to diversify the conventional cropping system with animals and then with trees. And try to combine all these three things all together in an agro-silvopastoral system. How we want to do this in AGROMIX project? We want to combine conventional research with participatory research to exploit what we call local ecological knowledge and scientific knowledge and expertise in a research-driven participatory approach. As you can see in the graph, in the figure, there is also a top-down, at the same time a top-down and a bottom-up approach in order to spread increased knowledge about this diversified system. The consortium of AGROMIX is huge. We are 28 partners, leading by the Coventry University. We have 10 universities, 7 research institutes, and 11 multi-actor partners. In Italy, there are 4 partners, and in particular also a farm directly as partner, where we implement several experimental sites. 3 are the aims crucial for the project: deliver a participatory research, so include in the research farmers, advisors, all the actors that play a role in the supply chain, in the several supply chain along Europe, provide practical agroecological solution, and explore the potential novel approaches to increase the sustainability and resilience of farming system. AGROMIX is based on a nested approach. We have co-design pilots, and then I will present you an example where several actors work together to increase the knowledge about these systems. We have experimental side to create novel knowledge with comparison with conventional and diversified system as mixed farming and agroforestry. And then we have 83 study sites where we collected information to create like a very huge bibliography about the diversification of cropping system. In particular, I want to present you the pilot projects, and in particular pilot teams. There are at the moment 6 pilot teams along Europe, and then other 6 pilots in the second part of the project. 1 is in Italy, and I want to present you what we call a cheese valley. The name of these pilots means that there are a valley in the southern of Tuscany where all the farmers are involved want to produce milk for a dairy product, very like delicious product like the Pecorino Toscano cheese DOP, and are based on the cooperative, the Caseificio Sociale di Manciano dairy factory. This is the structure of our multi-actor group. We have 4 selected farms. We have also cheese factory board engaged in this group, local advisor, regional policymaker, scientists, obviously, we and our other scientists, local NGOs based on an environment, more thinking about a more environmentally friendly agriculture, and local and national retailers. We are working to create a wider group and with a local network, with more number of farmers and more number of actors. As you can see, the valley of our cheese valley and the cooperative of Caseificio Sociale di Manciano are based on more or less 200 farmers, more than 40,000 hectares of utilized agricultural area, and 7 million liters of milk per year. The majority of the farms are have a surface lower than 70 hectares, and the sheep per farm are low there, 300. So we are talking about a very local and small farm typology. What we are going to do in these pilots, we want to analyze and characterize the system altogether, the stakeholders, and a brief of requirements. What we want to do, we want to tackling environmental and agronomic needs to create a common and co-design innovative farming practices. Why? As you can see in the slide, the southern part of Tuscany is a lovely place, no? Where beautiful agro-silvopastoral systems, as you can see on your right, and why we want to increase sustainability. Probably this is just sustainable. Probably not. We have a lot of problem about soil, in particular, are about soil carbon loss due to tillage and soil erosion, as you can see on your left. We have to remember that the Mediterranean basin, and in particular the Tuscany, as you can see in the slide, suffer to a very high rainfall erosivity, and you can see also soil erosion phenomena during winter and autumn. During summer, we have a lot of problem of drought, and in particular climate conditions that affect soil protection and animal health and animal welfare. And you can see on your right there is like a lot of needs of shade and cooler temperature for the sheep. How we want to do? We want to make an agroecological transition. We want to start reducing tillage, increase polyculture inside farms, increase the presence of meadow and grasslands, so increase the portion, the share of perennial crops instead of annual crops, integrate crop and livestock systems, so create a system where grazing are a very rational management to increase the sustainability of the system, and then build agro-silvopastoral system where also trees can be crucial and can lead the ecological benefits of the presence of trees inside farms. This is a structure of the system analysis. We started in the 2021 with a lot of workshop to understand the system and actors of the system, the design. Now we are working together to create and tailored and ameliorated the system for our value chain, and then we are going to assess through a multi-criteria sustainability assessment the level of the actual situation, the current situation, of the farm. We want to work with farmers to create a self-assessment tool able to increase the knowledge of farmers, but with data, not only with qualitative approach, but with quantity and our data methodology, a self-assessment of our sustainability and resilience level. Then we want to create a wider group of actors and talking about the sustainability and landscape level in order to assess the suitability of our pilot territory to the transition towards mixed farming and agroforestry. We also started several field activities. This is a tree plantation of poplar for timber production, but also forage resources production to use trees as forage resource. That's all from my side. Thank you for your attention, and I leave the floor for the question.
Thank you very much, Alberto. Very interesting project. So we have just a few minutes for the question. So I start from the last one. Is a question for Giulia. The question is, do insurance companies considering stepping in the carbon credit markets as providers of carbon credits insurance instruments for carbon futures? This is the question from Michele, if Giulia can answer.
It's a complex question and a complex market that we are in some way evaluating because we are defining as a group our climate strategy that will be launched at the beginning of next year. And of course, we have some relevant carbon emissions that we have to reduce more and more to be in line with the Paris objectives. But of course, we can have also activities that generate potentially carbon credits. So I can't say that much on it in this moment, but it's a strategy and a market that we are evaluating.
Thank you, Giulia. The second question is for Luca, and the question is the follow. If in the project were carried out some plots for grazing of young cow or only for sheep? If you can understand the question.
Yes. Yeah. Sure. Yes. Actually, we didn't have any, let's say, field activity with the cows grazing, but in the toolkit we try to stimulate the adoption of these practices by livestock farms in this territory. Actually, there are pilot experiences that are not within our demonstration farms, but are involved in other ways into the projects. They participate in our events and demonstration days. So we have a dialogue opened with farmers using grazing, also with cows that are in production, not only with young cows. With young cows, I mean, it's easier. Actually, it's a widespread practices, no? Having young cows outside. With the production cows, it's more difficult, especially because I mean this the supply chain of Parmigiano Reggiano is based on really productive farms, And so actually, yes, there's a lot of talking about it, how to introduce this practice in a wider way. But actually, it won't be touched by the project. Actually, maybe another time. There will be another time.
Thank you for the answer. The last one was a question to Professor Dinelli, and it was a question about activities, if in the project they did the screening for varieties on millet and on sorghum, and Professor Dinelli now is at lesson, but the answer he made was they carry out partially screenings on varieties in the experimental farms. So they did this screening on the new variety, but is not completed this type of experiments. So thank you very much for your attention. Sorry.
Can I make a fast question?
Okay, another question.
No, can I make a question?
Yes, you can. Obviously, same. Thank you.
I would like to ask to Raul Belmonte for the project DIVERFARMING. I saw that you measured some negative nitrous oxide fluxes, so I would like to ask you if you have some explanation for this phenomena.
Because in the soil, you can hear me, no? Yeah. In the soil, sometimes there is an absorption of the nitrous oxide, and the bacteria use that nitrous oxide. So in some cases, when there is not high fertilization rates in the soil, they can be as a sink of nitrous oxide. So it has been seen in some management that the nitrous oxide can be trapped or absorbed in the soil. Instead of being emission, they can be a sink in the soil. So it is something that it is not strange. It can happen.
Thank you, Raul. Other questions? If not, we stop this first session on about networking of the project with Life Agrestic. And we take 10 minutes for a break, and in the following session, the scientific international section will be managed by Alberto Mantino, so he will coordinate the presentation and then the discussions. So see you in 10 minutes. Thank you very much. Agrestic è un progetto che è un po' il nostro fiore all'occhiello, perché è un progetto molto importante, è un progetto inserito nel programma LIFE della Comunità Europea. I partner hanno diversi obiettivi in questo progetto. Partiamo dall'Università Cattolica. L'Università Cattolica ha l'obiettivo di sviluppare dei nuovi modelli previsionali per l'implementazione e lo sviluppo di nuovi strumenti per poter aiutare nelle scelte tecniche. L'Università Cattolica inoltre ha anche un compito per valutare anche i sistemi culturali dal punto di vista della fattibilità e del ritorno per quanto riguarda il ritorno economico per l'agricoltore. Easy Agroservice, che è una società che fa miglioramento genetico, ha il compito di individuare le specie leguminose più performanti nei diversi areali italiani e anche le specie di copertura per poter sequestrare del carbonio dell'atmosfera
e rigenerare anche la fertilità del terreno. New Business Media ha tutto il compito della comunicazione e della divulgazione. Arter, come agenzia dell'Emilia Romagna, ha il compito importante di valutare i servizi ecosistemici e una forma di pagamento dei servizi ecosistemici per gli agricoltori, deve studiare il ciclo di vita e l'impatto ambientale delle varie colture nelle varie filiere. Infine anche ha il compito di validare la possibilità di rendere operativa e utilizzabile per l'agricoltore questi benefici dell'adozione di tecniche culturali più rispettose per l'ambiente. La Scuola Superiore Sant'Anna di Pisa ha un compito anch'esso molto importante, che è quello di modellizzare le emissioni in agricoltura, per cui qui a Cabosco, che è una delle 3 piattaforme che abbiamo in Italia, le altre 2 sono a Pisa e a Foggia, ha installato questo strumento, qui vediamo lo shelter, al quale sono collegati delle capsule sul terreno che permettono di monitorare 24 ore su 24 per questi 3 anni del progetto le emissioni che fuoriescono dal terreno, per cui anche dal punto di vista strumentale abbiamo messo a punto un qualcosa di veramente unico e innovativo per il nostro paese.
Ci troviamo ora nel cuore della sperimentazione AgRestic presso l'azienda agricola Cabosco a Ravenna. Alle mie spalle abbiamo lo shelter, che è la cabina dal quale vengono raccolti i dati dalle nostre camere di accumulo posizionate in campo. Le camere di accumulo misurano i gas emessi dal suolo ogni 15 minuti, quindi si chiudono per la raccolta del dato e si riaprono in maniera automatica, e sono 8 in totale, 4 posizionate sulla coltura di mais, che è la cultura diciamo convenzionale, dove le indicazioni culturali vengono date dal fattore dell'azienda agricola, mentre le restanti 4 sono posizionate nel campo della cultura leguminosa che abbiamo scelto nella rotazione innovativa. I dati appunto raccolti all'interno dello shelter vengono poi inviati direttamente alla Scuola Superiore Sant'Anna, ai loro server, dove dopo un'applicazione di controllo qualità del dato vengono rielaborati per la modellistica.
Orta nello specifico, oltre ad essere il coordinatore del progetto, ha anche diversi obiettivi, una in particolare è quella di migliorare i nostri strumenti di supporto alle decisioni, i nostri DSS, sviluppando dei tool specifici come il tool della scelta varietale, per esempio, indirizzando la scelta degli agricoltori verso quelle varietà che possono meglio catturare le sostanze nutritive dal terreno ed avere delle performance ambientali superiori alle altre. Ha il compito anche di sviluppare un DSS per quanto riguarda il tipo di lavorazione del terreno, che è più rispettoso di quelle che sono le risorse naturali, anche che può prospettare i migliori benefici in termini di energia consumata e di resa produttiva. Inoltre anche ha il compito di sviluppare e di implementare sui propri sistemi informatici dei tool per la gestione delle colture di copertura. Questo aspetto del progetto AgRestic sui siti sperimentali è incentrato su una parola chiave. La parola chiave è sistema colturale. Se noi vogliamo studiare, valutare, cercare di ridurre quello che è l'impatto dell'attività agricola, non dobbiamo studiare una coltura singolarmente, ma dobbiamo studiare questa specie nell'ambito dell'avvicendamento.
Uno degli obiettivi principali di AgRestic è quello di andare a valutare anche la sostenibilità della coltivazione. Sappiamo tutti che coltivare tutti gli anni la stessa cultura è molto impattante, è quindi importante effettuare delle rotazioni. Però ci sono impatti diversi anche a seconda del tipo di rotazione, e quindi all'interno di questo progetto, nei 3 siti sperimentali, qua a Ravenna dove ci troviamo, a Pisa e a Foggia, sono studiate 2 tipi di rotazione per località con 4 colture, quindi rotazioni da 4 colture, quindi 4 annate. Sono rotazioni con colture e gestioni convenzionali, con invece colture e strategie di gestione più innovativi, in modo da andare a vedere le emissioni di una rotazione più convenzionale rispetto alle emissioni e quindi alla sostenibilità di una rotazione invece più innovativa. Ad esempio, innovativo cosa vuol dire? Qui a Ravenna vuol dire una rotazione con almeno una leguminosa ogni 4 anni, che è cece a Pisa, pisello qua a Ravenna e lenticchia giù a Foggia. Ma poi vuol dire anche coltivare ad esempio il frumento duro in bulatura e quindi in consociazione con un'altra coltura. In questo caso noi stiamo facendo degli studi del frumento in consociazione con una leguminosa e quindi principalmente l'erba medica. Questa consociazione permette di avere una coltura che si svilupperà nel momento in cui noi andremo a raccogliere il grano, quindi giugno-luglio, e quindi andare a coprire l'appezzamento durante il periodo estivo, impedendo lo sviluppo di infestanti nel periodo estivo, fissando azoto appunto perché le leguminose sono delle azotofissatrici grazie alla loro attività simbiontica, e quindi strategie che aiutano a ridurre magari l'uso di prodotti fitosanitari e di concimi. Solo cercando appunto strategie di riduzione di questi mezzi tecnici possiamo ridurre le emissioni e quindi gli impatti ambientali e quindi migliorare la sostenibilità delle produzioni. Sostenibilità vuol dire produrre senza ridurre la fertilità del suolo, in modo tale che le generazioni future possano avere la stessa fertilità e possono ottenere la stessa produzione dai terreni, dagli appezzamenti, e quindi avere colture che fissano azoto, che migliorano la struttura, che evitano lo sviluppo di infestanti, mi permette di usare meno mezzi tecnici e quindi ridurre l'impatto ambientale.
È naturale che questo tipo di progetto abbia avuto l'interesse di diversi stakeholder. Noi abbiamo circa 20 stakeholder che sono coinvolti nel progetto AgriStick e qui vedete tante colture perché abbiamo dietro tante filiere. Per esempio prendiamo la leguminosa, qui abbiamo il pisello verde, varietà Aviron, fa un pisello raccolto secco che viene utilizzato dalla ditta Andriani per fare dei maccheroni della pasta gluten free e che ha una quantità proteica molto alta, per cui riesce a raggiungere un mercato molto particolare che è sempre più in espansione. Ma abbiamo anche il grano duro, stakeholder importante di questo progetto è la società Barilla. Barilla ovviamente è molto interessata a ridurre gli impatti ambientali delle coltivazioni, che rappresentano il 70% dell'impatto ambientale di un chilo di pasta deriva dalla coltivazione in campo. Il rimanente 30% deriva da tutta una serie di operazioni che sono la produzione della semola nel mulino, la produzione della pasta, l'essiccazione e l'imballaggio. Vediamo che la parte agricola nella produzione di un prodotto che poi viene venduto nei supermercati o nei negozi ha una parte importante e dobbiamo cercare di ridurre questa. Poi abbiamo il pomodoro, per esempio qui a Cabosco, il pomodoro. Perché? Perché abbiamo anche come stakeholder la ditta Mutti di Parma, che è un'azienda leader per la produzione di concentrati, di salse, di pelati, tutti a base di pomodoro. Perché anche loro ovviamente sono interessati a capire come poter ridurre gli impatti ambientali delle loro coltivazioni. A Pisa abbiamo come colture, essendo un areale un pochino più caldo, meno piovoso, e anche a Foggia abbiamo anche altre colture che sono il girasole che coinvolge come stakeholder la società Tampieri e la società Coppini, che lavorano sul girasole altoleico. E infine sia a Pisa che a Foggia abbiamo anche l'orzo maltario per la birra. Anche questo è coltivato per esempio a Foggia sia con la trasemina delle leguminose che senza la trasemina delle leguminose, e gli stakeholder sono Peroni e Agroalimentare Sud, che fornisce il gruppo Heineken. Questo progetto se riesce a dimostrare il valore di riduzione in termini di emissioni di un sistema culturale ragionato, prevedendo tutte queste misure, i DSS, la scelta varietale che sfrutta meglio la fertilità, l'uso delle cover crops, eccetera, eccetera, cosa potrebbe dare? Potrebbe dare quasi una label, un'etichetta del prodotto finale, un'etichetta ambientale che raccoglie e condensa in se stessa i benefici che derivano da una corretta gestione dell'avvicendamento. Un altro aspetto importante è quello dei pagamenti ecosistemici che vengono studiati da Arter. Sono delle forme di remunerazione anche dell'agricoltore, perché l'agricoltore per fare queste cose ovviamente fa degli investimenti. Sono interventi questi che devono essere valorizzati dal punto di vista della produzione, perché l'agricoltore, scegliendo un sistema culturale idoneo, un sistema culturale particolarmente performante, non fa soltanto un beneficio dal punto di vista produttivo, ma fa anche un beneficio generale per quanto riguarda la riduzione delle emissioni.
Okay. Okay. Good morning. Let's restart with the second session of the morning. It's a pleasure to chair this session and introduce Marc Bernard. Marc Bernard participates in the coordination of the operational part of the International 4 per 1000 initiative, which aim to demonstrate that agriculture, so very focus on the morning session, in particular agricultural soil, can play a crucial role where food security and climate change are concerned. So, please, Marc, the floor is yours.
Hey, thank you. I will launch my presentation. I hope that goes well. I share my screen. I'm sitting here in Benin, West Africa, and connectivity is not very good. Can you see my screen?
At the moment, no, but okay. You can start. Okay. Yes, you can start, Marc, please.
Great. I go slowly because connectivity is poor, and I'm expecting that, it's changing all the time. So I'm going to present to you an outline of the CAP/MIL initiative, Soils for Food Security and Climate initiative, and attached to this a twin region idea that came out of my participation to this contribution to this initiative. So I'm actually, since May, I'm working with the initiative since 2000, 2019. I started in Madrid at the COP25, and I'm now the Network and Global Facilities Coordinator at the Executive Secretariat of the CAP/MIL initiative. You will understand my position a bit during my presentation. So, of course, it is about soils, and it's very much about soil health. Yes, I think what I also saw this morning, we're all struggling a bit with soil organic matter and soil carbon sequestration because it's so difficult to prove impact on soil carbon content in a reasonable time, in an economic, interesting time span. So we often need many years to see an impact on that. And this is something I would like to also think everybody. I think we should more go towards carbon farming and see the total organic carbon balance of a territory, and seeing soil health and soil carbon as one of the soil health have an important effect and an important factor in this, and see soil organic carbon just as a component of a total sea balance. I think this is just a recommendation I'm giving personally. So this is the subject CAP/MIL is dealing with, and we're interested in regulation of greenhouse gases. But as we see with agriculture and forestry and land, let's say integrated land management, it is not just we don't have only a regulation of greenhouse gases. We also have a lot to do with reducing infrared emissions from our territories. We have an enormous impact on the water household with our activities. And I think that too, we should have a more integrated view in the future and not just focus on greenhouse gases. There are very interesting work happening in other areas that we should try to integrate with. Now, what is CAP/MIL? Actually, it was launched, it is a multi-stakeholder platform. And I'm very much like this more Italy-focused conference because it gives more detailed insight into what's happening in municipalities like Cento and more in the various provinces, and going down to youth and working with schools, canteens, and others. I very much like this integrated approach to see how do you actually solve this as a societal environment. And I think this is a bit what CAP/MIL is about, learning across from Italy and applying it all and share it with peoples in Argentina, in Bolivia, in Africa, in Asia, and everywhere. So and sharing it also with other stakeholder groups like government, international organizations, relevant producer organizations, and NGOs. So it was initiated by France in COP22 in 2015. We have about 666 member organizations at present, including 40 countries that are represented with their government. So we have a quite high potential power. Potential because I think we could make more out of this. But it all depends on you as well. Some of you are partners of COP4Mill, and this is why I'm in here. It is a pool of about 2,000 professionals with different skills and backgrounds. This is very interesting for building networking and collaboration. We can all learn from these different people. Our vision is to achieve worldwide healthy soils and carbon-rich soils, combat climate change, and end hunger by 2050. The mission is really to promote soil health and carbon sequestration and facilitate transformative action that we've heard of this morning a lot. Approach, of course, decentralized. We're not an organization, we're an initiative, and we're hosted at the SIA Biodiversity, it's our secretariat, and we try to promote decentralized collaboration, networking, and very much also, we're very much aware that this is a complex issue. It's not complicated. It's not about thinking about a solution. It is about getting involved and improve our solutions with time. So it's more about emerging solutions. And very much, and I like this morning very much, I saw many faces of farmers and even a lady cooking and others. So this is very important, this direct involvement on the ground. And the primary beneficiaries of our initiative are producers, citizens, and facilitators. Facilitators are the people actually helping producers and citizens who solve climate-related issues. Now, we have developed in 2020 a strategic plan together with our members that has 6 areas of intervention and 24 objectives. I don't want to go much into details. Each objective has a clear target, what we want to achieve. So we're trying to cover all areas that concern soil health in relation to climate change and food security for 2050 vision. The clusters are more kind of phases of innovation cycle management. So inception and conception of projects, implementation, we have promotion of actions, collaboration, that how can we improve follow-up, and cross-cutting issues. I cover that later in my presentation. Now in 2021, we did something very interesting. We made a Delphi study to develop our implementation strategy. So we had a strategic plan with our goals and what do we want to do, but we didn't actually know how to implement, what activities do we have to invest in to get there. So the Delphi study was, the aim of the Delphi study is to come up with an implementation strategy that is solidly rooted and is represented, that is rather objective and representative and owned by our partners. So it was not that we as a secretariat proposed this, we wanted to build this implementation strategy with our network. And we wanted to produce a document that can be served as a reference document for our partners. That can be used in project planning and programs, that can be used for coordinating and targeting investments and activities, build confidence of it. So we wanted to have something which objectives and helps us to gain the confidence of investors. And then evaluating, that is also used for us to evaluate progress we're making. So what we did, the implementation strategy for each objective responds to 5 key questions. What is the problem that the objective wants to solve? What are the underlying causes of this problem? What are the activities that we have to undertake to overcome to address the causes and overcome the problem? What are critical success factors, and what are barriers that might be difficult that we have to overcome to achieve the objective? So those 5 questions were at the center of the Delphi study. And for those who are not familiar with the Delphi methodology, I'll just make a short outline. So first, we send out these questions to all our experts of our task forces. So we had about 330 experts to whom these 5 questions were addressed. And we collected from elements from response. Then we analyzed the feedback that came back and made a summary report. Say, listen, for these objectives, this is the problem, these are the causes, these are the activities that are proposed. So it's more kind of collecting it and make a summary. We shared this summary again with all experts and say, listen, this has come out of the first round. Please, do you feel this covers all aspects? So it's your aspects considered. Are the other aspects that came in by other experts, are they also considered? And this is, we elaborated a draft implementation strategy. So this is what happened in the past. I could show this to you. So participation was really great. We had 124 experts from all over the world participating and from all stakeholder groups that you see here. At the bottom, you see the stakeholder group. So we had a total of 191 studies completed. It takes about half a day to complete the study, just to tell you a bit of how much these people invested. And we were very happy because it makes our strategy. You can actually visit it for those that have a login. I'm not going to do this because of connectivity reasons. I could try, but I'm a bit afraid to do that with my connectivity. Contact my server, so it takes a long time already. Sorry, I'm not going to do this. Yeah, can you still hear me?
Yes, hello? We can hear you. Okay. And also your troubles.
Sorry. But I had to stop this.
Don't worry.
Oh, I made a mistake. I stopped the presentation. I have to launch it again. Sorry, this is all not so easy when you're working in a developing country. So, is my presentation visible again?
Not yet.
No?
Yes, now you can restart, please.
Okay, thank you. So we were very happy with it, and it makes our implementation strategy very solid. Please have a look at it. Following this link, you will find I hope that my presentation will be shared with the people attending here. Now, what we want to do in 2022, based on this implementation, we have defined activity for each objective. Now, what we want to do is build partnerships and alliances, supporting and assisting transformative actions across the globe. And I would be happy if also from Italy, partners would engage in this global action. Now, just to give you an idea of how CAPCOMIL is organized, we have an executive secretariat, we have a scientific and technical committee, we have the forum of partners, the 666 partner organizations. They are organized in task forces, and we have consortium members who have a voting right. So they're actually directing and steering the initiative. And we have a bureau which is meeting every 3 months to address issues that come out of the forum from the different stakeholder groups that they can address at our bureau meeting and steer our second activities. So we have quite a democratic system established. Our target group are the beneficiaries, the citizens, producers, and facilitators. Facilitators are from the private and public sector and the NGO, the civil society, who assist producers, so NGOs and others. Now, what we want to provide to the beneficiaries is legal and financial support through the provision of core facilities. We're partnering with development organizations and big donors to provide these facilities, and this is the main focus of the Executive Secretariat, to assure legal and financial support to citizens, producers, and facilitators for transformative actions. And we have a range of different facilities that we have defined on the basis of our implementation strategy. The second one is global facilities. It's more kind of the scientific and technical assistance. And we're working here with our task force members to build alliances. So this is more about scientific support and technical support. So these are the two sides are actually improving the enabling environment for transformative action. And this is the main purpose of CAPCOMIL, improve the enabling environment through global collaboration. What we do to get this done, decentralized, we're collaborating with ongoing projects and initiatives at the various regions in Asia, in Latin America, in Northern America, in Europe. So we're trying to develop roadmaps with these people, with the governments, with the regional institutions, the development banks and others internationally, to develop such roadmap that actually promote and support the provision of global facilities and core facilities. This is a bit a simplified version of it that you might be more easy to explain. So we're focusing on building of partnership and alliances to provide this and roadmaps. These are the three areas of intervention of CAPROMIL. Now, what do we want to achieve? We want to have projects implemented, alliances and partnerships that implement projects on activities defined in the implementation strategy. We want to improve the enabling environment for transformative land use in line with the vision of the CAPROMIL initiative. And we are aligning, and we want to align with other alliances and partnerships and the relevant ongoing policies and programs for optimal impact. So with all the projects we heard of this morning. By the end of 2022, we would like to be able to facilitate the formation of partnership and alliances, the elaboration of concept notes. We will not go down to full proposals. This is the role of partners themselves, that we want to facilitate to bring them together and develop project concept notes. And then we hope that partners have submitted corresponding project proposals for funding organizations according to their specifications. So according to their two funding organizations, according to their specifications, because each funder has a different procedure. We all love European Commission for being so simple, making it so simple to apply for funding. We've all gone through that. Now, project concept note, I'm just showing this for practical reasons. So what we're facilitating at CAPROMIL, we bring together partners, which we say, listen, you could form an alliance, and they would have a project title, then reference to what strategic objective they want to contribute. And then we would have start date, end date, the coordinator of this alliance, and then have work packages, the expected results, the project leader, start date, and the resources required. So it's a simple tabular format, which makes out a concept note, a project concept note, which we would promote at the levels of donors and seek for funding. Once we get a positive signal, then the project leaders will develop a full proposal. That the reference to our implementation strategy has a considerable political weight. Sorry, the plane is just crossing my hands. Good. Now, to get this done, we're now presently in a phase of coordination that will be completed by the end of February. After that, simultaneously, we'll see needs. We will be in exchange with producer organizations and NGOs that work at grassroots level to assess needs. We will write to our partners and indicate their competences, and we will write to investment to funding bodies to say what type of action are you willing and where are you willing to invest how much. So we want to identify priority areas where we say we are sure that there is a need in the field, we're sure that our partners have the required competences, and we're sure that we will find funding for these activities. So we're not wasting investing into alliance building without having a chance of success. And this will be a priority area. So it's an intersection between the three, the needs, the competences, and the fund that will define a priority topic. And then we will start building these partnership alliances around, we hope that we'll start with developing these concept notes somewhere in May 2022. So, and that we finalize with identifying priority topics somewhere in March. Good. Now, let me explain to you twin regions. It's a particular mechanism to make sure that we have an impact on the ground. This idea came to my mind when I was attending the COP25 in Madrid. I saw this huge chunk of land of Africa, and I just said how I'm going to fund activities in Africa to make sure that we do not miss out opportunities we have in Africa to sequester carbon. So And I had the idea, my region, your region, let's come together and solve the climate crisis together right now. What is the objective of the region?
Sorry, Marc, 2 minutes.
2 minutes. Oh, sorry. Twin region action, 2 minutes, impossible. Twin region concept seeks a framework decentralized. So I shall show you what a twin region looks like. It links up with the beneficiaries and the cross-cutting action of our operational framework. The objective is to bring together, just go back, to passive reforestation has a big potential across the world to lower carbon sequestration. Now, what we want to do, look at this graph. If you look a bit how much emissions European Union countries produced since 1960, it's 295 gigatons of carbon. Sub-Saharan Africa, 13%, 30 gigatons of carbon. If you look at the land area where we can sequester carbon, it's exactly the opposite. Africa has a huge potential as compared to the European Union, whereas Europe has a huge financial, economic potential to do something. So the two regions are complementary, and I want to bring them together. To give you an idea, I bring together regions. I will just go to this image. Imagine Alfter, this is a community in Germany where I live in Germany. When I'm there, we're producing about 300,000 tons of CO2 emissions a year. And on the other side, we have Copago, a community here in Benin, which is producing about a tenth of the emissions. Although there are 3 times more people, but due to poverty, they're much less responsible for the climate crisis we're in. Now, if you look at the land area, Copago is about 30 times bigger than Alfter. Alfter by no ways can compensate for its emissions by improving carbon sequestration on the 3,400 hectares of the size of their community. Whereas Copago can easily do that by improve, but they are lacking funds. If you look at the GDP, it's about per annum, it's about $1,300 per capita in Copago and $45,000 in Africa, in Alfter. So what I want to do is, we want to bring them together and create a carbon market between these two regions. So Alfter is collaborating with Copago to sequester the emissions they are having. And they do this by fostering integrated land management in both regions. So we have the CO2 sink region needs to develop credible carbon sequestration offer here in Copago. For example, they could specify the area suitable for active and passive afforestation, describe how they would proceed with carbon sequestration, and what system they will use to demonstrate how much they have achieved. On the other side, you would have the CO2 source region, they need to express their demand for carbon sequestration by implementing carbon accounting system and equitable cost-sharing mechanism, like what they're currently doing for waste and wastewater management. And price of carbon sequestration will be a question of offer and demand. I just got a message, I guess. Okay. Offer and demand. That is presently about 50 to 150 euros. So what makes it so attractive? This approach would allow a very fast completion, the complementarity of regions, and this, for instance, approach allows a drastic reduction in reduced time and cost needed for solving the climate crisis. Equality and fairness, polluter pays principle will lead to a redistribution of wealth that is expected to set in motion a virtuous cycle of development that will enable key social and environmental problems such as poverty, migration, and biodiversity loss to be addressed. Free up resources. Solving these fundamental problems will free up resources that are currently invested in mitigating their negative effects and will enable the transition to a system of environmental and social and cultural responsibility for sustainable development that benefit all. low transaction costs, exchange and transaction costs between twins takes place directly. Thus, there are less costs for intermediary activities, as the case is with interventions that are led by government and external organizations. Employment opportunity will generate a lot of employment opportunities in the regenerative section. Proximity and ownership, citizens that can experience changes directly and can closely monitor the impact of their efforts and adjust their actions as necessary. So I'm just going through the other ones. I think the last one, success, if the movement takes off and we really get a vast number of municipalities in industrialized countries and countries of development collaborating in this way, we can create a successful movement that will produce a proud generation that can celebrate its achievement in 2050. Now, we're developing presently Kickstart, but all I want to show you, please go to this link. I'll share it in the forum, Twin Regions, to learn more about the concept. And if you're interested, I would be happy if you would register so I can keep you informed about developments. Thank you. The time was very short, and I'm sorry for going beyond time.
Thank you so much, Marc, for this brilliant and impressive presentation about the 4-Mill project, strategy and action, really. Thank you so much. Now it's time for me to introduce Marco Acutis. Marco Acutis is a full professor in agronomy and crop science at the Department of Agricultural Sciences of the University of Milan, and is going to present us how to model GHG emissions from agricultural soils. So, Professor Acuti, the floor is yours, please.
Hey, I'm trying to share my screen and to start my PowerPoint presentation. I think that all works well. It is?
Not yet. Okay.
Very good.
Can you use the presentation mode, please?
I'm in the presentation mode.
In the full screen mode, sorry, Professor.
I'm sorry, but I am in this mode. I tried to prove the situation if something is changed. Now it's okay?
Now it's okay. Great.
It is okay now, sorry.
Yes, you can start, please. Sorry, can you reopen the presentation?
Yes. I share screen. I go back to the presentation. Now it's work.
Yes.
Oh, very good. I'm sorry for the inconvenience. So, my presentation today is about modeling the greenhouse gas emission. So I prepared the outline that you can see on the screen. What are the greenhouse gases involved? What are the drivers of soil emissions? What are the models that we have to simulate this soil emission, and some note about applicability and performance to the model. Now I have a problem. Next. Okay. Agricultural activity emits several gases, but not all of these gases are greenhouse gases. So from soil, we have for sure the emission of CO2 that is due to respiration of microorganisms and root respiration. Consider that we estimate that the share between the two sources are 50-50. But the range can change a lot according to the different conditions. The other important gas is methane. The methane is produced near exclusively under anaerobic condition, so from submerged soils. In normal condition, there is very little methane production, or the soil can act as a sink of methane. So, in terms of agricultural fields, the problem of methane is limited to paddy rice. It is limited not because paddy rice is one of the most widespread cultivation in the world, so it is not a small problem, but is quite different from the other problems. Consider that one molecule of CH4 is equivalent to 28-30 molecules of CO2. So there is a strong greenhouse potential. But the gas that was more recently studied and understand in terms of their greenhouse potential is N2O. N2O have a very high greenhouse potential. The CO2 equivalent is between, according to the different estimate, between 250 and 300. So the risk from N2 emission is very big. What are the origin? N2 emission are mainly from agricultural activity. What are the origin of the emission of this gas is during the nitrification process, so when ammonia becomes nitrate, and during denitrification that happens, the last one, in condition of soil full of water, where the porosity is filled by water. And so from the nitrate, we go to N2. But if there is some lack of organic matter for the anaerobic microorganism activity, we can produce also relevant amount of N2O. Only recently, it is at least 10 years, we know that there is also release of N2O by nitrification, but we don't have to forget it. In country where there is relatively low amount of water, there are not groundwater close to the surface, this emission by nitrification that was not studied in the past, it is the most important form. Soils emit also a large number of other gases. For example, NOx, the oxide of nitrogen, that are very relevant, they are dangerous, but they are not directly greenhouse gases. This is not a good reason to forget it. Last, but absolutely not least, from the soil, we have ammonia emission that contribute to secretion of particulate that is very dangerous directly, but these two last gas are not included in my presentation. What are the drivers of the soil emission? There are a very large collection of drivers. The system can be the emission can be really different under different conditions. Here, there is a synthetic image that indicates meteorological and weather condition as important. The temperature, the radiation, more important is the soil water content that usually when we work in forecasting gaseous emission, we express in terms of filled pore space by water, water filled pore space. Obviously, it is absolutely important the amount of nutrients. Plants absorb ammonium and nitrate. Natural microbiology produce nitrate even if you don't put nitrate in the soil. So nitrification is absolutely a key point. Carbon and carbon dynamics, more stable, more degradable organic matter create different conditions. Vegetation that uptake the nitrate in a very different way. And so on. Almost all factors that create the dynamic of our growing fields can regulate, can create conditions different for gaseous emission. In particular, there are two main drivers. If, obviously, if there is no nitrate, no carbon, no nitrogen, it is dominant the availability of the elements. But given a fixed availability of an element, it is water, soil content, and temperature the most influent factors. Not that the dynamics are very different between the different gases. You can see that for CO2 emission, there is an optimal water content. This is the optimal for biological processes degrading carbon. CO2 is emitted during the degradation, the composition of the carbon and mineralization. And you see the classical scheme about CO2 with optimal moisture condition that decrease when there is too much water in the soil, anaerobic condition, and when there is a lower availability of water. But for N2O, the trend is quite different. It is relatively low at low water content. After start nitrification, there is a peak of nitrification about very approximately when 60% of the soil water is filled. After, we have a mix between anaerobic and aerobic condition. Maybe in some cases was reported this small decrease here, and after anaerobic condition, denitrification and N2O emission. Methane, no emission up to the starting of anaerobic condition, and after we go directly to the best. The replay of the system to the temperature can be very different because there are, here is represented a rate considering the rate at 20 degrees. And the replay to the temperature is very, very, very different from the different gases, and we doesn't know exactly what is what of the curves or the curves between a specific category are allowed and are experimentally measured. So we are in a condition where we don't know exactly what is the replay of the system to those important variables. The There are also other drivers very important as fertilization, amount of soil organic matter. So if we don't simulate the carbon dynamics in the soil, we don't have any possibility to simulate correctly the gaseous emission. We have the residuals and the CN ratio of the different components of organic matter in the soil. We have the tillage. The tillage can be very important, more oxidation, or emission of CO2, but maybe also a reduction of emission of N2O. There is a contrasting opinion about this. In some case, conservation tillage, minimum tillage or no till decrease the emission of N2O. In some cases, increased it respect to standard conventional cultivation. And also the soil reaction in terms of pH and liming play an important role in determining all those gaseous emissions. So what kind of approach we have? We have absolutely the need to planning our cropping system to understand what will happen with the new climatic trends that we will, unluckily, we will have, even if we try to contrast in all the possible way. Climate change is what we are, unluckily, waiting. So we cannot do experimentation in future climate. We cannot do experiment in all the real conditions. We have to plan the resilience. We have to plan better cropping system that actively fight against climate change. So we have a different approach. Today, the most common approach is to use the IPCC approach that is based on emission factor. So it is not a model because there is one step between the input and the output. In the case of emission factor, that is interesting for inventory at country scale, for example, of regional scale. It is a very simple approach, and IPCC say your emission of N2O is 0.01, so 1% of your input of nitrogen, with very little differentiation between the different type of nitrogen that is put in input. So it is 1% only solved? Absolutely no. The IPCC itself show a big range of variability, do not have strict criteria to set better values, and so it is good for very large scale assessment where can be useful to have very general relationship, but not for a specific assessment. Other steps, typically for field scale, plot scale, up to small regional scale, we use the process-based model. Process-based models are computer software that try to translate our scientific knowledge in a set of equations simulating step by step the behavior of a so complex system as our cropping system. They are able to predict daily or weekly the emission of gases, and together with a lot of other relevant parameters of the agricultural system. For example, yield, very important, obviously. For example, leaching of nitrate, also that is very important for environmental quality. In particular, in the case of greenhouse gases, where there are present in traces like N2O or methane, the situation is better for CO2 prediction. The models are very complex and rely on site parameterization and calibration. You have to use this model at this level, at our level, actual knowledge, you have to calibrate the model on real data that are extremely important. When they are calibrated on real data, we can apply it for simulation of other alternative cropping system or for understanding the effect of climate change. Note that a big part of the algorithms taken in the model comes from laboratory-based responses to individual environmental factors. So, for example, you put in incubation soil at 15, 20, and 25 degrees. But what is the interaction between the different factors? So, even if it is quite easy and absolutely needed to construct curves of response of specific factors driving variable in the lab, it is after a problem to translate this knowledge in the practical system where the interaction between the different different drivers is really big. So if we are a very good level to simulate yield, a very good level to simulate leaching, not at the same to simulate yield, the model are not at the same very high level of performance in simulating greenhouse emission. In this slide, there is a list of different models. The most famous, Descent, the NDC, EPIC. We have a very large amount of model. It is very difficult. If someone asks me what is the best model, I'm not able to reply absolutely, because we don't have one best model. What is the best model? The model that was calibrated at the top against real data. So, for example, Descent is relatively weak in water dynamic simulation. DNC, that is probably the NDC, that is probably at the top of the modeling in terms of simulation of different categories of microbiota that works in the different condition, is relatively weak in water simulation because, for example, it is not able to handle a water table. It is not strong in crop simulation, so maybe weak in simulating roots. There is not in-depth simulation of tillage animal. It is a very complex model, excellent in hydrology, and you have seen how is important the soil water content, but it is very difficult to use from the technical point of view, and so on. So the choice is very difficult, but obviously the idea is apply it to several to experimental condition, calibrate it, and at the end choose the better. But you need some time to learn how to use this different model. Again, I put the attention, I need 2 or 3 minutes to finish, so I'm just in time, on the calibration. The model are based on the quality of calibration. Look at this graph. This is the observed point on the x-axis. And here there is simulation, the green point with an uncalibrated model, and after with the same model calibrated with automatic, very high level procedures for 47 parameters on the basis of real data. So yes, we have a big improvement in R square from 0.0 to 0.7, but not in the slope. Not that we are very far from the one one-to-one regression line. Again, water-filled pore space is the key point to have good simulation of gaseous emission. Promising novelties, coupling machine learning algorithms with already available model. Model give basic values. For example, accurate model for hydrology give basic values of water-filled porosity, and after we can use more simple data to fit using machine learning objective algorithms, the N2. So there are a kind of mixed process and machine learning model. SIM, even if it is absolutely very recent, the publication about this concept are done in this year. So we are at the first attempt, but it seems really promising. So I go to the conclusion. Conclusion are, we have absolutely the need to estimate the emission. Pay attention to the balance between CO2 emission, carbon storage, and N2O. So we need a model that consider both, not only one of these: carbon dynamics, carbon storage, CO2 emission, and other greenhouse emission. At the moment, the model are, even if there are some problems, the best results that we have to planning future cropping system to obtain low environmental impact. The simulation at this moment are just sufficient. Sufficient is better than nothing, but we have the possibility to improve more. The emission factor are not good to planning cropping system. They are done for other purpose. Machine learning is very promising, but as I say during all the meeting, the need of more research, but research shared, based on shared approach with all the stakeholders, large participation of all. Thanks for you, and sorry for the longer presentation that was 4 minutes longer than my 20 minutes.
Thank you so much, Professor Acutis. Really brilliant presentation, also because they showed future perspective of modeling about greenhouse gas emission in agricultural soil. So now it's time for the last presentation. I will introduce Camilla Moonen and Federico Leoni, researcher and postdoc researcher respectively of the Institute of Life Sciences at here, Scuola Superiore Sant'Anna, with a presentation about ecosystem services in the Mediterranean intercropping and systems. So please, Camilla, the floor is yours.
Okay, thank you. The H2020 project IWM Praise to this very interesting conference of AgriStick. The IWM Praise project is a European project working on the integrated management of weeds and looking for locally adapted sustainable solutions for integrated weed management. And so as Scuola Sant'Anna, we have developed part of this, this project, and we've been looking for agroecological solutions in intercropping systems. And it's very nice to present this work here because Horta, for example, was the partner with whom we developed the part of the project that we're going to present this morning. So you can find more information about this project and other locally adapted solutions that were invented in other regions of Italy and other regions of Europe for different cropping systems on this website. So today we are going to try to connect the use of legumes for intercropping to think about what ecosystem services can be provided by these legumes. And we've listed some of the very important potential ecosystem services that can be provided by legumes. So the most important one when you think about legume intercropping is, of course, soil fertility. Another important issue is soil organic matter increase, which is especially in the south of Europe an important point. In this case, of course, for our project, weed suppression was extremely important. You can also think about intercropping to produce a secondary crop, and this can be the case if you use, for example, alfalfa or lentils or any other grain legumes. And it can play an important role for soil erosion, as we've already seen in other examples this morning. And they could also support, for example, pollinating insects and to provide nectar and pollen for pollinators, but also for other beneficial insects that need these resources for their life cycle. So in this study, the main services that we were looking for in the selection of these legumes was to, first of all, control weeds, and secondly, to improve soil fertility, and with the objective to reduce the use of agrochemicals and fertilizers. As I said, we performed this kind of twin study together with the colleagues from Horta, and we included in this selection also the study of looking for the right management options for farmers to find those solutions that are sustainable in their local context. Because as you may know, all these agroecological solutions, they are sustainable from an environmental point of view, but they may cause problems with applicability and ease of use and also economic sustainability. So we need to really combine to provide farmers with the information that helps them to select the best possible solution in their local context. So we can never end up with a list of saying, okay, you have to do this, this, and this, and then this and this will happen, and that will provide you with wonderful yields and reduce environmental impact. So what we really need to do is provide them with information that helps them to choose what to do in their situation with their objectives. And so what we tried to do with Federico this morning is to very briefly give you the outputs of 3 very important management choices that a farmer has when he thinks about intercropping with legumes. And these 3 issues are the time of sowing of your intercrop, the sowing method, and the legume choice. So I will talk about the first 2 options, and then Federico will talk about the legume choice. So as I said, we set up this twin trial together with Horta, and Horta managed it in their experimental farm in Ravenna, and we tested this system in the Agro-Environmental Center for Centravanzi in San Piero a Grado, which is just near Pisa. So this Pisa site was basically a low, we called it a low input site because it was almost organic farming, even though it wasn't certified, but we tried to really reduce inputs as much as possible to, first of all, because in Tuscany, systems do not have a very high yield potential. So investments in the system are normally lower with respect to what a farmer in the northeastern part of Italy would do. And so by decreasing this even a little bit more, we could really see what services could be provided by the legumes in the system. And so the target objective of this system was to establish a cover crop that could cover especially the soil in summer in between the wheat harvest and the sowing of the next summer crop, and then to provide a green manure for the next summer crop. So in this way, to reduce fertilization to this summer crop. And in the Ravenna side, we had an integrated management system where the crop was managed by local, like standard local management using the granodura.net decision support tool, which was, of course, as you all know, developed by Horta itself. And in this area, farmers are very interested in this intercropping with legumes solution, because if they use a forage crop in the cereal, then they can kind of anticipate the establishment of a forage crop and have already kind of win 1 year in their crop, breaking their crop rotation with a forage legume crop. So in these two systems that were so managed according to the kind of local standards and desires of the farmers, we tested 12 different legume species. And kind of inside these experiments, we have tested something about sowing time and sowing methods. So the first management option that farmers have to think about is whether they want to contemporary sow the legume with the cereal, or whether they want to kind of relay sow the legume into the cereal. And contemporary sowing simply means that you need a machine that allows you to sow the cereal and your legume at the same time. So you would do that kind of in October, November time. And in the relay sowing option, you would first sow your winter cereal, and then sow your legume inside the established cereal crop by the end of winter, just before stem elongation. And so what you see here on the picture is an example what happens if you have a contemporary sowing. So the legume and the cereal, they develop together. And this is what happens if you do relay sowing, where the wheat is already established and the legume has a little bit less space and light to establish and will remain a little bit lower in the crop. And yes, so this is basically two pictures showing what happens at the harvest time with these two different sowing types. I hope you can see that in the contemporary intersowing, the legume is much more developed and can even reach the height of the crop. Whereas in the relay sowing solution, you see that the legume remains very low underneath the crop. And of course here it depends very much on what is the objective of the farmer, if this is, which of these situations are useful for you. So from a weed management point of view, as you can see in the relay intercropping, the legume kind of managed to cover the soil and so competes with weeds for space. So from the weed control point of view, this works. Although you can see that at wheat harvest, you have about half the legume biomass production. But the question is whether you wanted that huge biomass at that time of the year. Because what happens is after wheat harvest, there will be more light, more space, and the legume, if the right legume is selected, as you will see later, can develop and cover the soil to be a good cover in summer, and then to also survive winter and be a good cover for the next summer crop. So I will anticipate that with the contemporary sowing, of course, there are some legumes that can be highly competitive with the wheat, and that can therefore cause problems with at harvest. And so this is basically what happens in the, so this was, sorry, I forgot to say, this is the situation in a low input cereal system. So where the wheat crop is not highly competitive. And this is the same situation in the integrated kind of higher fertility system, where both in contemporary sowing and relay sowing, the legume remains quite low underneath the wheat because the wheat stand is much, it covers the soil much more and is much more competitive. So in this situation, even if you would have a highly competitive legume, you would probably be able to control it in such a way not to cause problems with wheat harvest. And you can see that the biomass production at wheat harvest is very low. But as I said already, this is not necessarily a problem, because at this point in time, you probably did not really look for a very huge legume biomass. So in conclusion, you can see here the comparison of legume biomass production. So it's the same, I forgot to say, it's the same cereal variety. In our case, it was Minos, which was provided by ISEA, which is a variety that is not very prone to lodging, and this can be important in these intercropping systems. And so the competition of living mulch with wheat can be much reduced in these low input systems or organic systems if you use the relay cropping approach. And the contemporary establishment, which is technically more easy, can be a good solution if you know that you have a well-established and dense cereal crop. So then the second, I pass on to the second management option, which is a sowing method that you can use to establish your intercrop. And here you can choose between broadcast sowing and direct drilling your legume. And so basically in relay intercropping, you have your cereal established during winter. And just before stem elongation, you can choose to either broadcast seed the legume or drill seed your legume. And basically, the broadcast seeding, of course, most farmers have a broadcast seeder present, so it can easily be established. The drill seeding is a little bit more complex from a technical point of view, because you need to be able to enter the field and have a seeder that allows you to drill your legume into the rows of the cereal. And for example, in our trials, we had a wider row width distance between the cereal rows, so we went up to 17, 18 centimeters. And of course, not all farmers have a machinery that allows them to do this. So if we now look into what effects this has for the spatial development of the living mulch, you can see that with the broadcast seeding, the plants are kind of randomly established into the crop, whereas in the drill seeding you have a row pattern that kind of optimizes the space between the wheat and the open space in the rows. And so are there any, the question is whether this kind of causes any problems or advantages in the system. And what we found in the low input system is that so we had 2 years of data to compare. In the first year, there was a kind of quite normal rainfall pattern. And as you can see, there were hardly any differences between the development in the broadcast sowing and the drill sowing approach, which are the light green and the dark green bars. In the second year, there was very low rainfall, as you can see. And so in this year, the drill sowing resulted in a much better establishment of the plants. And so what you basically see that if you're in an optimal situation where you have optimal soil conditions, very no crust, not too wet, not too dry, etc., broadcast seeding kind of works quite well. But if you have any compromising situation, then row seeding provides a much better solution, and it allows you to really optimize your resources. So just very short to conclude about the advantages and disadvantages of this. So the broadcast seeding, as I said, it's more rapid, less costly, and it can be widely applicable. But the point is that you may have to increase seeding dosage. And of course, based on the choice of your legume, this can have a very important impact on your economic balance of the system. And at the same time, the broadcast seeding doesn't really allow the seed to be in very close contact with the soil. So that causes this susceptibility to kind of not optimal conditions. The drill sowing, it really helps to the legumes to establish, because the seed is less susceptible to unfavorable environmental conditions, but it's slower. You need this specific machinery to allow you to do this, and not all farmers may have access to this. So I now ask Federico to tell us something about the choice of the legumes.
Thank you, Camilla. Thank you all. The legume choice is a fundamental aspect for sustainable application, a successful application of living mulches. We are talking about relay intercropping, and relay intercropping involves the sowing of the legume in late winter when the wheat is already established. And from this point to the wheat harvest time, legume and wheat grow together in the field. And which characteristics legumes should have during this period? Well, we should select the legume according to specific growth characteristics in order to maximize the beneficial effect of the living mulch and minimize the risk of competition between the living mulch and the main crop. This is until the wheat harvest. After the wheat harvest, according to the legume that we used, different legume can work differently, in particular according to the different biological cycle of the legume. We can use, for instance, perennial legume. Perennial legume are expected to persist in the field and increase their biomass, since that the competition of the wheat, there is no more competition from the wheat. And according to the farmer need, this legume can be used or for the forage production, in the case we use, for example, Medicago sativa or Trifolium repens, or they can be incorporated into the soil in order to support the production of the following crop, that in our case was the sorghum. We can use also self-seeding legume. Self-seeding legume, for example, are Trifolium subterraneum or Medicago polymorpha. They are it's a quite interesting option, because the peculiarity of this legume is that they can regrow spontaneously from their seed in the following autumn. Basically, during the intercropping period, they spread the seed on the soil surface, or they actively bore the seeds in the first layer of the soil, and they are able to regrow from their seed in the following autumn, establishing a dense cover crop until the following spring. Notably, during the summer, they persist in the soil, they persist in the field as dead mulch, so there is no water competition. They do not need water during this period. In the following spring, they can be terminated and incorporated into the soil in order to support the productivity of the following crop. Finally, we can use annual legume. Annual legume, the biological cycle of annual legume terminates at the same time of wheat, and if they are able to produce enough biomass during the intercropping period, they can persist in the field as dead mulch during the summer and until the following spring, reducing for the risk of soil erosion, or competing with wheat for germination and growth. We know that several factors affect the performance of the living mulch, and in particular, according also with the results that we obtained from our experiment, we know that the cropping system management strongly affect the performance of the living mulch. In particular, we focus on two contrasting target cropping system. We focus on integrated cereal-based cropping system in Horta and in a low-input cereal-based cropping system. Basically, in an integrated system, there was the growth of the wheat was supported by the use of optimized dose of fertilizers, whereas in a low-input system in Pisa, we did not use the fertilizers. And as you can see from the picture, we used the same variety of wheat, the same experimental design, but the performance of the living mulch is completely different. In the first case, the biomass accumulation, the canopy height of the living mulch is quite low, whereas in the second case, in a low input system, the biomass accumulation, the biomass production, and the canopy height of the legume is very high. So in a low input system, we know that it's very important to select suitable legumes because the competition from the wheat is lower and they grow characteristics and behavior is very different according to the species. In fact, there is a very strong species effect in the performance of the living mulch. If we compare the biomass production or the canopy height of the legume used in our experiment, we can see a very diversified situation. For instance, the wheat reached the maximum canopy height of 1 meter, and the maximum canopy height of the legume used in the experiment ranged from 10 centimeters to 80 centimeters. In particular, Trifolium resupinatum and Trifolium incarnatum had the highest canopy height, whereas the other legume, Medicago sativa, Medicago polymorpha, Trifolio subterraneum, Edisarum coronarum, and Medicago lupolina and Trifolium repens had a maximum canopy height from 10 centimeters to 17, which are, according to the canopy height, this legume seems more suitable for this system, because they grow in a complementary layer compared to the productive layer of the wheat. So I'm presenting two pictures that just to show you two contrasting situations and just to highlight how it's important to select suitable legume for when we decide to use a living mulch. On the left, we have a picture with wheat and Trifolium resupinatum, which is an annual legume. And on the right, we have a picture for Trifolium subterraneum with wheat. As you can see, the Trifolium repens completely sovrasted wheat, causing a problem during the mechanical harvest operation, whereas in the case of Trifolium subterraneum, we can see that they grow in a very complementary layer, and so Trifolium subterraneum can be a suitable legume for this system. So the selection of legume can be based on in low input system according to growth characteristics of legume, in particular canopy height and biomass production, in order to maximize the beneficial effect of legume and minimize the risk of competition. The screening, the results of our experiment show that Medicago sativa, Trifolium repens, Edisarum coronarum, and Trifolium subterraneum can be the best option for the living mulch to be used as a living mulch in low input system. The situation is quite different in integrated cereal-based cropping system, where where the production is supported by the use of nitrogen, and for these reasons also the competition of the wheat on the living mulch is higher, because there is not a significant species effect on the living mulch. The biomass accumulation of the legume used in living mulch was lower, was uniform, and also the maximum canopy height reached by the living mulch was the same, and there was not a species effect. But even if there was not a species effect, the selection of the legume is still important, because we need to understand that the presence of legume during the intercropping period have a significant effect also after the wheat harvest. And in this regard, I'm presenting 3 examples of living mulch: Trifolium resupinatum, Trifolium subterraneum, and Medicago sativa. Of course, Trifolium resupinatum and Trifolium subterraneum cannot be suitable for this system, because the performance of the living mulch are strongly correlated with the biomass accumulation of legume during the intercropping period for the annual and for the self-seeding legume. While for Medicago sativa, the situation is quite different, because the performance of the living mulch is strongly correlated not on the biomass accumulation of legume during the intercropping period, but on the density of plant during the intercropping period. In fact, this plant, the perennial legume in general, in particular, Medicago sativa and Trifolio repens, are quite tolerant to a shade environment, so they can be tolerant to the competition of the wheat. And after the wheat harvest, when there will be not more the competition of the wheat, they can grow more. So the criteria for the selection change, and now the selection should be based on the tolerance of legume to the wheat competition in order to ensure a good persistence of the legume after the wheat harvest. And in this regard, Medicago sativa and Trifolio repens seems the best candidate to be used as living mulch in integrated cereal-based cropping system. So, just concluding, we know that the living mulch can provide important ecosystem services, but several practical aspects should be addressed for the successful application of the living mulch. In particular, if we decide to use a living mulch in a high productive cropping system, the contemporary intercropping is the best option. Regarding the sowing method, the direct drill seeding ensure a better establishment of the living mulch. Otherwise, we can use also a broadcast sowing of the living mulch, but the sowing dose, the seed dose should be increased by 30%. And the Medicago sativa and Trifolio repens in this context seems the best, the most suitable legume to be used. The situation is different in a low productive or organic cropping system. And in this case, the relay intercropping should be preferred because we know that the competition of the wheat is lower, so we need to give an advantage to the wheat in order to reduce the risk of competition between living mulch and wheat. The sowing method, again, the drill sowing is the best option, but in case the specific machinery are not available, we can use also perform a broadcast sowing. And in this case, Medicago sativa, Trifolium repens, and the Isaro coronarum are the best, the most suitable legume. If water is not a limiting factor, also because after the wheat harvest, this perennial legume needs a little bit of water for a successful establishment. If water is a limiting factor, we can use Trifolium subterraneum. Thank you for your attention.
Thank you, Federico. Thank you, Camilla, for this impressive presentation about your project results. And now, before ending, there are some questions, in particularly for Marc Bernard. I asked to Marc, he is still connected. He is still connected. Marc, are you online? Marc? Probably not. Okay, so I want to ask you to Alessandro Bosso to give some insights about the 4 per mil project, because Alessandro is a partner of the Life Agrestic and also a member of this very brilliant project about the 4 per mil strategy and action. So please, Alessandro, can really 2 minutes about something about the project, about the 4 per mil strategy. Please, the floor is yours. Just a moment. Alessandro, we cannot hear you. Just a moment, Alessandro, wait.
You can hear me.
Okay, please.
Now you can hear me?
Now we can hear you. Please, please, Alessandro. Not yet.
Still now?
Now. Please start.
Okay, thank you. Excuse me for this mistake. The 4 per Mille initiative is born in COP26 and is a global initiative to reinforce and enhance the carbon sequestration in soil, in agricultural soil and in forest soil, and to reduce agricultural emission. And Arte is a partner, is member of the forum and the consortium, and has participated to the development of the strategy that Marc showed us in his speech, and also in the developing on some tasks of the implementation plan that have several goals, and it can be a sort of link for Italian subject interested in participating or to have information about this initiative, that has also had a meeting in Glasgow in the last COP for the parties, and is an international initiative that go beyond the EU borders and involve at global level, in particular African and South American. I don't know if there's some specific question about the consortium or the role of the forum of the members.
No, there are a question. I can ask you to reply to this question.
Okay, Marc, perhaps Marc is now available because he raised the hand.
Yes, I'm back.
Okay, Marc.
I had a problem with my internet.
Thank you, Marc.
There is a question for you, Marc. According to your experience and opinion, which are the best practices to be adopted on a large scale in the CO2 sink regions with high ecological potential to meet the 4 per mil goal? Like ecosystem services, afforestation, reforestation, livestock management. Can you respond, please?
Yes. Thanks for this good question. I'm really facing this. The problem is that I'm facing here in Africa now, where I've been working for many, many years, for 30 years. It is, how do you get to integrated land management? And I think that all components, technologies, must be considered. You know, we have here a situation, we have pastoralism, agriculture, forestry, working alongside. So very many times in an African setting, you still have very much an integrated land use management system where land ownership is not really focused in the hands of individuals, but more at community level, and where things are negotiated between different stakeholder groups, like the pastoralists, the forestry people, and the agriculture. So I think it depends a lot from region to region, from ecosystem to ecosystem. And what I think is most important for us is to look at soil health. I think that's the key issue. I'm not so much personally, my opinion, I'm not so much a friend of looking only at carbon, organic carbon content, because you might have shifting carbon content where you have carbon, organic carbon, fixed in the soil, which is mineralized to feed trees, which in return fix more carbon than you have actually mobilized in the soil. So it is a very dynamic system. And I think that we all have to forget a bit looking only at one component or at one technology, but more having integrated system. And this is where I think is local knowledge. And I'm sure this is in Italy the same. To include this into our development of solutions, it is absolutely important to have, I can maybe switch on my video, but I'm afraid about my connection. This is why I'm hesitating. To have this integrated, and this is what I liked very much this morning when I saw a bit how people are actually discussing with people locally and finding a solution. I think basically there is no solution that fits all sizes. And I think that collaboration with people and proximity actually the key factors on which I would surely focus in the future. I think there are many technical solutions that are viable, but it depends on the situation. Yes. And I think it also is important that you not only look at your field or at your farm, but that you really think about your responsibility within the entire system. So I think this is important. And I liked very much the first presentation when it was, we're working with youth. I think this is really key, that we start, this was on diet, but I think at all levels to start to raise awareness at the youth level for this integrated management and to come to a lifestyle where it's not just grab what you can, but more is how do you actually make a living in a more integrated system of stewardship. Yes, that's with and I think this is where Capumil will end up in, trying to enable this transition to a more sustainable lifestyle. This is, yeah. And I hope, of course, that Twin Regions will be, I'm going to push this very hard here while being here now in Africa, yes, to get support from the international community and from research organizations to come to these kind of models where citizens don't delegate their responsibility, but live up to their responsibility. Thank you.
Thank you so much, Marc. I have two quick questions for Federico. The first one, did you have in mind to test a multi-harvest annual legume like Trifolium alexandrinum with an ecotype like Saidi instead of the other legume species?
We tested a lot of annual legume, Trifolium alexandrinum not, but and the specific cultivar as well. But in general, annual legume seems not so suitable for this system.
And the second one is, did you have evidence that mixture of legume species could perform differently, better or not, respect to pure species of legume stands?
Thank you. Hopefully this will be the next step, because we think that the mixture can really work better compared to the sole legume used as a living mulch. And we believe that for the mixture between perennial and annual self-seeding legume can be a good option and perform very well, but we need to test it.
Okay, I have the last question for you. The last question is based on the evidence of your works and your experiments. The competition between alfalfa, Trifolium repens, and wheat are more affected. So the biomass reduction of these legumes are more affected by shade, so light reduction, or water competition.
I would say shade competition, but again, alfalfa and Trifolium repens, we know also according to the bibliography that they are tolerant to shade environment. So they persist, they are alive, but they reduce the biomass accumulation rate in case of shade environment. And for this reason, they are quite promising for a living mulch system, in particular for integrated system where the competition of the wheat is quite high, because under the canopy of the wheat, the light is very low. So we need plant tolerant to the shade environment, to a shade environment.
Thank you so much, Federico. So, yeah, I'm going to close. So the last question from Pierluigi, please.
I want to thank Federico and Camilla. Okay. I want to thank Federico and Camilla because IWM Prize project was very well connected with Life Agrestic, and we adopt in a field scale the intercropping of legumes, and successfully, and with a high production of biomass. And
thanks to you for this presentation, and but also thanks to this network of project that is really very useful to translate a specific and scientific approach to a field scale, and it is really an example of success. Thank you.
Thank you so much, Pierluigi. So I'm going to close this very interesting session. Just a few comments because we are not a huge delay, but more or less. So a really big thank you to all the people involved in the organization, all the presenters and all the people here in present, all the people connected. Really was a very successful and very useful 2 days of mid-conference for the Life Agrestics. So thank you so much. Enjoy the rest of the day and see you soon with all the information from the Life Aggressive. You can visit our website, our Facebook page, and all our social media. So thank you so much. See you soon.